So these steps that we have, they stay the same every single rational graph. And you can kind of simplify them as in, you need to find asymptotes, and you need to find nice points. You like to simplify it down to 2. Now, to find the asymptotes, you're going to have to factor completely non-permissible values, get you your vertical ones, and then you have to look for horizontal or oblique. And then once you have your asymptotes, you need your nice points, which includes all of your intercepts, and sometimes we need more points and sometimes we don't. So all we do now till the end of the unit is just practice more of these. And with every single one, something interesting or a little bit different happens, but the steps stay the same. So if we're doing A here, we'll factor first, so we notice that the bottom is a difference of squares, get x plus 2 and x minus 2. And we can write out our non-permissible values, that x can't equal negative 2 and x can't equal 2. And now we have to decide, are those non-permissible values wholes, or are they going to be, are they wholes, or are they going to be vertical asymptotes? Now, if they cancel out, they're going to be wholes. They don't cancel out, they're not identical, so they will end up being vertical asymptotes at x equals negative 2 and x equals 2. Next, what group is this? The degree is bigger in the denominator. You don't formally have to memorize, oh, that was group 3. You're never, on the exam, if you write group 3 and someone from another school division is marking it, they'll have no idea what you're talking about. But since the degree is bigger in the denominator, we have a horizontal asymptote. I think this one's the easiest because it's always at y equals 0. So I can go and start my graph. And I'm going to have an asymptote at negative 2, and a 2, and a horizontal asymptote at y equals 0. Perfect. So step 1, get your asymptotes. That's how we get our asymptotes. We're going to need to factor. We're going to find our non-permissible values. Next, find some nice points. We're always going to find intercepts. Y-intercept is the easiest. I like to go to the original pre-factored one and plug in 0 for x. We get negative 4 over negative 4. That's 0, 1. I have a point. X-intercepts. If we're going to have an x-intercept, it's where your numerator is equal to 0, because you're going to plug in 0 for y. And the only place a fraction ever equals 0 is if your numerator is 0 and it's already in a factored form. It's going to be 4, which feels a little weird. Oh no. There it is, right on my asymptote. That's a little bit awkward. Okay? Now, our asymptotes split our graph up into 3 sections. And if we have points in the sections, we usually can graph. Usually. Okay? In the middle section, you can graph it. Why? Because if it's going to go towards an asymptote, it either goes up or it goes down. But if it goes down, you get a new x-intercept. Part of the reason we find the x-intercepts is we find them all. Therefore, we cannot add any more. So because we can't add any more x-intercepts, we would know this would have to go up. Otherwise, you would invent a new x-intercept, and we already found all the x-intercepts. Okay? Section 3, we have a point, but it's right on the asymptote. So we actually don't know, does it go up or does it go down? We have a problem there. And in section 1, we have no points whatsoever. We have a problem there. So we need more nice points. And that's just a matter of plugging anything into the equation and finding out where it is. So in section 1, x minus 2 is my asymptote. I like to just go 1 over and see what I get. If you plug in minus 3, and you can go here to the original, minus 3 minus 4, can you see that your numerator would be minus 7? Minus 3 squared will be positive 9, minus 4, you would get negative 7 over 5. So we're really kind of pushing the boundary of what we call a nice point, because normally you like try to avoid fractions, but not in this. You're like, any point is nice, as long as you have a point. So negative 7 over 5, that's going to be about here. Label it negative 3, negative 7 over 5. And now I have enough to say, yeah, I could go towards the asymptotes. That section is done. Because I don't know which way it's going, I'm going to plug in positive 3 and see what happens. So again, I'm going to go up to the top here. 3 minus 4, that would be minus 1. And I get 9 minus 4, I still get 5. I get negative 1/5. Okay. So I have 3 comma negative 1/5. And that tells me, oh, it has to go down towards that asymptote. But it's still a little bit unclear what happens to the right of that x-intercept. Like, should it go above the asymptote, come back down? Should it go below, come back up? It eventually is supposed to go towards the asymptote. But right now it's on the asymptote, so it's a little bit of a problem. So whenever you have a problem, find another nice point. Let's see what happens when I plug in 5. If I plug in 5 into the original equation, I will get 5 minus 1 is 1. 25 minus 4 is 1 over 21. 5 comma 1 over 21, which is above, right? Just barely above. So it's going to come above and then eventually go back down. I don't know exactly where it gets its maximum. You're not going to be worried about that. But this graph goes through the asymptote, goes slightly above, and then it comes and starts coming back down again, which is weird. I'm going to tell you that rational graphs sometimes are weird. And they're all a little bit different. But they're predictable in that as long as you find enough nice points that you eventually can go towards the asymptote, you're going to be fine. Yes.
So what you're saying is rational graphs are irrational.
Rational graphs are somewhat irrational. Well, no, because we can make sense of them. So they're still rational that way. Just, they don't, what we like as rational, we're used to like, it looks the same every single time. Isn't that nice? It's a parabola. It still looks like a parabola. It still looks like a parabola. These ones are like, what just happened on this one? Okay, let's do B.
You know, when you divide a parabola by a line, it's going to be weird.
If parabola divided by a line equals weird, sometimes. And sometimes, I mean, I guess if you've done enough of them, you start to feel like they're more predictable.
Sorry for the interruption. Could we have the grade 12 student council to the office, please? That's grade 12 student council. Please come to the office.
Uh-oh, in trouble.
I'll be back.
Okay. All right, so we can factor this one. Two differences of squares are non-permissible values. Again, you're only worried about your denominator because the only thing you're not allowed to do is divide by 0. So x can't equal negative 3 and 3. And in this situation, they don't cancel out. So any non-permissible that doesn't cancel out will be a vertical asymptote. So we have two vertical asymptotes. The degree is the same in your numerator and denominator. This was group 2. You have a horizontal asymptote at, and you just look at the highest degree, and the coefficients in front would be 1 over 1. So we have a horizontal asymptote at y equals 1. And we can start graphing. are our two vertical asymptotes and our horizontal asymptote at y equals 1. So we can start with our nice points, our y-intercept. Again, looking at the original equation, I'm going to get -4 over -9, which is 4/9. 0,4/9. X-intercepts. And this is where it's nice that we factor. There's going to be 2 of them. Because in our factors, -2 would make our numerator 0, and +2 would make our numerator 0. And when we look at our sections, section 1, section 2, section 3, we have enough in section 2 to draw our graph. But we have no point in section 1, we have no point in section 3. So since my asymptote is at -3, I would pick another nice point at -4. We'd go to my original equation, or you could go to your factored one. Either one is fine. If I plugged in -4, you see that you would get 16 minus 4 is 12, and 16 minus 9 is 7. So I get 12/7. Is 12/7 above or below my asymptote? Above. So that's going to be important that you label it. So we got -4, comma, 12/7, and that is enough to draw this section in the asymptotes. We need a point in section 3. Can you see why the mental math for this is going to be super easy? Why is it going to be super easy for me to do the mental math when I plug in 4? Okay, plug in -4 here, plug in +4, sorry. Giving away my hints and everything. It's exactly the same as -4, right? When you square, it's going to be the same thing. So we're going to get 12/7 again. Which kind of makes sense with the x squared. Do you see that there's going to be symmetry on either side? And if we look at this graph, once I label this point here at 4, 12/7, and I draw it, this graph is perfectly symmetrical over the y-axis. We call graphs like this even functions when they're symmetrical over the y-axis.
Any other questions for this question?
Yes, the questions for this question are 9 and 10.